All right, the pesticide DDT was widely used until it was banned because it is toxic to a wide range of animals and aquatic life, and is suspected to cause cancer. DDT takes a long time to disintegrate after it is sprayed. The chart below shows the amount of 100 grams of DDT remaining in the environment after a certain number of years. So we can look at our chart after 1 year, there were 50 grams remaining, 2 years, 24.8, and so forth. Okay, it asks us to make a scatter plot for the given data. Sketch your results below. I would definitely suggest on this one to use the TI Nspire unless you'd like a piece of graph paper. You can ask before that, but if you use the TI Nspire, you're going to get a graph that looks something like this. Okay, so you're going to get something like that. One thing that I will ask on the scatter plot, and I will mark you down if you don't have it, the X values were the years, and the Y value was the DDT, or the grams, if you wanted to put that instead. So we should label your X and your Y axis, and it's exactly what you put in your list on your calculator when you did your scatter plot. Okay, does the linear or exponential function model the situation? I will definitely say exponential, and then it asks us to explain, so I would like a complete thought when you're explaining. I will say the model is exponential, and we can actually wait and explain this till after we actually find the model, or I'm just going to say when I look at the graph models an exponential curve. So I'm going to say the model is exponential because the scatter plot forms an exponential curve. Okay, and then it says to create an appropriate model for the situation, where if it's exponential, I know I'm going to have y equals a times b to the x. And to get the b, if you remember, we're going to backwards divide. So I'm going to backwards divide that first set. I'll get 0.5024. If I backwards divide the second time, I'll get 0.5208. If I backwards divide again, I will get 0.48. Backwards divide again, I will get 0.504. If I backwards divide again one more time, I'll get 0.496. So we can tell that the numbers are close. They're not exactly the same. If I wanted to actually find what that b is, we could take the average of those numbers, and if I do, I end up getting 0.5. So my b in this case is going to be 0.5, right? And then if you remember, to get the a, we can just backwards divide one more time because we'll get from 1 to 0. So we'll take 50 divided by 0.5, and 50 divided by 0.5 will give me 100. So my a value will be 100. So my exponential curve is going to be y equals 100 times 0.5 to the x. All right, and then the last one, it says to use your model to determine how many grams of DDT will remain 120 years after it is sprayed. So we'll have y equals 100 times 0.5 to the 120. And then if you use your calculator for that, you're going to get one of those strange answers again. You're going to end up getting 7.5 e to the negative 35, and remember that just means 7.5 times 10 to the negative 35, and if you really were feeling great, that means to move the decimal to the left 35 places. So you could actually have, you could actually end up getting you're going to have 34 zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So that's how many grams you would have, but it would be just as appropriate to leave your answer like that. All right, the keyword for this video is pesticide. All right, the table below shows the number of U.S. households with personal computers from 1994 to 2002. So 1 year after 1994, which would be 1995, there were 35.1 million households with PCs. 6 years after 1994, which would be the year 2000, there were 50 million households with PCs. So it says to make a scatter plot, and once again, I would definitely suggest to go to the TI Nspire for this and go ahead and make yourself the scatter plot. When you do, you're going to get a plot that looks something like that, and I do make sure that I label. So this was years, and this was the households with PCs, or you can even put PCs or something like that. That would be fine. And when I look at this, I definitely can tell it is a linear function. I'm going to explain in conversation language. So I would say the function is linear, and then I'll just say why, and it's because I could say the data is going up by a constant rate. I could say the graph forms a line, so I'm going to say because the scatter plot forms a line, or the data is changing by a constant rate. Either one of those would be fine. All right. Create an appropriate model for the situation. Well, if this one is linear, we know we have y equals mx plus b. To get the m, to get our growth rate, our rate of change, we are going to backwards subtract. So we're going to backwards subtract. When I do that, I get 3.5. Backwards subtract, I'm going to get 2.7. Backwards subtract, I'm going to get 3.1. Backwards subtract is 2.9. Backwards subtract, I get 3. Backwards subtract, I get 2.8. And backwards subtract, I get 3.1. Okay, and once again, notice they're pretty close, but I don't have a for sure slope, so I'm actually, again, going to take the average of those numbers, and if I take the average of those numbers, I get 3.01. So that will be my slope. So I just found that m was 3.01. Now remember, again, b is just your starting amount, and b is where it hits the y-intercept, which would be at 0. So I can just backwards subtract one more time. So I'm going to backwards subtract 3.01, and when I do that, I get 32.09. So my model is going to be y equals 3.01x plus 32.09. All right, and then it says to use, and again, I would definitely suggest now graphing that on your scatter plot to make sure it was a good fit. All right, number 8, use your model to determine the number of households with personal computers in the year 2012. Notice that household numbers are given in millions. All right, 2012, we need to figure out how many years that was since 1994, so we're just going to take 2012 minus 1994, and that gives us 18 years. So we're going to take our model, we're going to have 3.01 times the 18 plus 32.09. And when I do that, I get 86.27, and it's just not 86.27 households, it's 86.27 million households. So make sure we include that million on your answer.